Hey, everybody. Welcome to day two. And day two is all about a specific type of counting method called permutations, which we introduced the word yesterday. And now we're going to get into it. What is a permutation? Well, a permutation is just this. It's a specific arrangement of objects. And this is the most important part, where order is important. And what do I mean by order is important? This is what I mean. Imagine someone owes you money and they owe you $654. And what if they say, you know what, I'm just going to pay you $456. You know what, it's the same numbers, isn't it? You know, hey, it's the same numbers. I'm just going to give it to you. Of course, you're not going to accept that. Why? Because you change the order of the numbers. And when you change the order of the numbers, you get a brand new permutation. So order is important means that when you change the order, you get a brand new permutation. That's what order is important means. Okay, so first and foremost, let's now get to a general rule. I showed you about the P notation yesterday, but what does NPR in general mean? All right, and I am going to write the formula. It's n factorial. Remember, that's not exclamation point. That's not n. That's n factorial. You can all say factorial. Okay, divided by n minus r factorial, where n represents total number of objects, and then r represents the number that you're choosing from the total, the number you're choosing from the total. Okay, so in general, r could never be larger than n. You can't pick more than what you have. R could be as big as n. In other words, you could have 10 things to pick from and you pick all 10 of them, but r could never be larger than n. All right, 4p3. Just want to show it once using the formula, and then I'll go back to the calculator. So if I use the formula, 4p3 is NPR, so that would be 4 factorial divided by n minus r, so 4 minus 3 factorial. Now, what does factorial just mean again? It means multiply your way down to 1. So that's 4 times 3 times 2 times 1. And 4, last time I counted, 4 minus 3 is 1. 1 factorial is just 1. Technically, I mean, although it really doesn't matter, but technically what happens to the ones here? Technically, they disappear. So you're just left with 4 times 3 times 2. And 4 times 3 times 2 is 12 times 2, which is 24. Done. You could do a permutation. This is called permutation notation. But 5p2. 5 factorial divided by n minus r. 5 minus 2 factorial. So that's 5, 4, 3, 2, 1. And the last time I counted, 5 minus 2 is 3, so 3 factorial. So that's 3, 2, 1. Hey, everybody, what happens to the 3s, the 2s, and the 1s? They go away. And you're just left with 5 times 4, which is 20. Ain't no thing. How about 6p4? Let's go to the calculator for this. Matter of fact, you can use your calculator for all these. I just wanted to show you the formula. So I'm going to hit 6, then go to math, just like yesterday. Go to the left twice to probability, and go down to option 2, which is NPR. 6p, what was it, 6p4? Yes. Hit enter, and you get 360. That's it. You can do it on your calculator. So let me go back to the sheet. 6p4 equals 360. Just for kicks, let's prove that 5p2 is 20. Just want to show you on the calculator. Might as well. 5, math, NPR, 2. And hopefully I'm a good teacher. It's 20. It's 20. Who knew? All right. So let's get back to the notes. So now you know what permutation notation is. Let me box this in red. And I'll box this whole thing in red right here. There we go. That is the formula. Do you need to know that formula? It helps. Will it be more helpful if you just know how to use your calculator? Absolutely. Use your calculator, everybody. I'm encouraging you. You're at home. If we were in school, I'd say, I know the formula, and I might give you some formula problems, but you're at home. I can't stop you from using the calculator, so I might as well encourage you to do it. Okay, in how many ways can we order all the letters in zebra? If this was yesterday's lesson, there's 5 letters in zebra. You know what that means? It means 1, 2, 3, 4, 5 dashes. So if I go old school, old school, 5 letters, 5 dashes, there's 5 letters to choose from at first, then 4, then 3. Once you choose a letter, you can't choose it again, then 1. Hey, wait, 5, 4, 3, 2, 1, that's 5 factorial. But you know another way to write it? 5p5. Because I have 5 letters in zebra and I'm choosing all 5 of them. And every time I change the letters around in zebra, I get a brand new word. Ladies and gentlemen, this is 3 ways of writing the answer to the same question. All 3 of these are equivalent. So when you take any kind of worksheet or quiz or test, I want to see what you're using to solve it, which is all this, and the answer. What is 5 times 4 times 3 times 2 times 1? 5 times 4 is 20. 20 times 3 is 60. 16 times 2 is 120. 120 permutations. I want to see at least one of these 3 on the left and this one on the right. That's messy. It's getting to me right there. It's kind of like when you leave something messy on the board. There we go. I changed it just for you guys. Okay, how many 4-letter arrangements in Hermit are there? So let's see, how many letters are there in Hermit? 1, 2, 3, 4, 5, 6. So there's 6 letters in Hermit, but I'm only picking 4 of them. So how would I write that in P notation? That'd be 6P4. Done. I could put that in my calculator. Didn't I already do that? 6P4 is 360. Done. By the way, could I have also done the dashes for this? 1, 2, 3, 4, 4-letter word, so 4 dashes. And there's 6 letters to choose from, then 5, and 4, and 3. Guess what? That also equals 360. Who would have thunk it? Mr. Clody, do we have to write permutation every time? No, you don't have to write permutation every time. And by the way, I think that's the first time in the video where I did that voice. Bringing it back. Okay, playlist consists of 15 songs. 5 tracks are played at random. In how many ways can these be played? So you got 15 songs to choose from, but you're only choosing 5 of them. Write that as a permutation. What is that? It's 15p5. You all know how to use this now on your calculator, so I'm just going to tell you 15p5 is a lot of ways. 360,360 ways. Or I'll say playlists. I'm just going to say permutations. But you got over 360,000 playlists if you're playing 5 out of 15 songs. That's a lot, right? You never thought about that. How many ways can a 4-digit bike lock be set without any repeating digits? So you can't use the same number twice. Not really realistic because, you know, if each of those little dials has 0 through 9 on, of course you can use the same number twice, but let's just assume you can't. So again, how many digits are there from 0 through 9? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 10 choices. So you have 10 choices, P, and how many are you actually picking? It's a 4-digit bike lock. So 10p4. So 10p4 is 5,040 permutations. In how many ways can you draw 4 cards from a deck of 52 cards? The order matters. The order matters. So that's 52p4. And that's a lot of hands right there. That's 6,497,400 possible card hands. In how many ways can a club with 10 members choose a president, a vice president, and a treasurer? Why does order matter here? Well, imagine you have a ballot, and on the first line, you're choosing the president. On the second line, you're choosing vice president, and on the third line, you're choosing treasurer. Suppose Kira wants to be the president. Are you going to vote for her second if you want her to be the president? No, you're going to vote for her first. Of course, I mean, everybody knows that Kevin wants to be the president too. So, man, it's a battle royale between Kira and Kevin. I'm just thinking of 2 K sounding names right now. But anyway, yes, you get what I'm saying. So 10 members altogether, but you're only choosing 3 of them, and the order definitely matters. That represents 720 ways to get this done. This isn't so bad, is it? All right. So now let's get to the final concept of today's lesson. Okay, so watch this. Distinguishable permutations. I'm going to get to the definition after I do an example. Let's take the word school. How many letters are there in school? 1, 2, 3, 4, 5, 6. So I would normally think, let me go back up for a second. Whenever you're using all the letters, like in zebra, wasn't that just 5 factorial? 5, 4, 3, 2, 1. Isn't that? Yeah. So it'd be, in this case, 6 letters, 6 factorial. Sounds simple to me. So I'm going to do 6 factorial ways. However, I want you to watch something amazing, and I'm going to come on screen for this. I am a magician. I can do crazy things. Watch this. I am going to take the red pen. Now watch the screen, and I'm going to cross off. Well, I'll cross it off in dark first. And then here's what I'm going to do. You ready? I just rearranged the 2 O's, and I came up with a brand new word. School. Oh, wait. I know I'm being absolutely corny right now. Of course, it's not a different word. It's the same word. Even though I flipped around the 2 O's, I got the same darn word. So in reality, this 6 factorial represents too many choices, because this 6 factorial means that if I change the 2 O's around, I get a brand new word. But we all know if you change the 2 O's around, you don't get a brand new word. So I have to divide away some of the terms. And here's what you do to divide them away. Because there are 2 O's that repeat, I divide by 2 factorial. And ladies and gentlemen, that is a distinguishable permutation, which I'll get to in just a second. I might do 1 or 2 examples and then show this. How do I do 6 factorial divided by 2 factorial? I mean, I could do it by hand. 6, it's not really that hard. I could just do 6, 5, 4, 3, 2, 1. And 2 factorial is just 2 times 1. What happens to the 2's and the 1's? They cancel out. And I'm left with 6 times 5 times 4 times 3. 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. That's one way to do it. Another way to do it is how you did last night's homework. Go right to the calculator. I could do 6 math, PRB, and then option 4 this time. Factorial divided by 2 math, PRB, factorial. And you get 360. Use your calculator if you want to. Piece of cake. But now at least I showed you how to do it by hand. Okay, how about Darth Vader? That's pretty good, actually. All right, how many letters in Darth Vader? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if all of these letters were different? If all the letters were different, there'd be 10 factorial ways to arrange them. Do you agree? Right, because 10 letters, 10 factorial. There would be 10 factorial ways to arrange them. However, not all the letters are different. How many letters repeat? I see definitely 2 A's there. So if there's 2 A's, Mr. Cody, they can be in 2 separate words. Sure, just one, really just one collection of letters. So I'm going to divide by 2 factorial for the A's. Then I'm going to look again. Are there any other repeating letters? Yes, there's 2 R's. So I'm going to divide by another 2 factorial for the R's. And this, my friends, is my final answer. And I'm going to repeat what I said yesterday. Mr. Collodi, can we just combine 2 factorial and 2 factorial and get 4 factorial? Unfortunately, there's no shortcut for factorial symbols, because this technically represents 2 times 1 and this represents 2 times 1. I know that's just 4, not 4 factorial. And no, it's not just the number without a factorial either. There's no shortcut, unfortunately. What you can do, you can go to your calculator. You could type 10 factorial divided by, anytime you divide by more than one thing, you need to start the denominator with a parenthesis. 2 factorial times 2 factorial. That looks exactly like what you have on your paper. 907,200 distinguishable permutations. Why are they called distinguishable? Because, let me go back. So 907,200 permutations. Because if I change these 2 O's in school, I can't distinguish that from the original 2 O's. So there, I divide away, and then there's that many distinguishable where the O's are in different places. Okay, not counting that. Ladies and gentlemen, so How do I do a distinguishable permutation? If there are, let's just say, n objects and one repeats, let's just say A times, and I'll say another repeats B times, and so on and so forth. You could have C times. The number of distinguishable permutations is n factorial divided by A factorial, B factorial, dot, dot. That's it. Pretty simple, actually. Okay, let's just go right down. Mississippi, the granddaddy of them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters in Mississippi. If all the letters were different, there'd be 11 factorial ways to arrange them. But now we divide. There's 4 S's, so 4 factorial for the S's. There's 4 I's, so another 4 factorial for the I's. And there's 2 P's, so a 2 factorial for the P's. Okay, and so if I work all that out on my calculator, I get 34,650 distinguishable permutations. That's it. How many distinguishable 6-letter numbers can be formed from 747457? There's 6 letters there, or 6 numbers there. And by the way, if it's a word problem, don't sweat it. Just see how many times things repeat. Divided by the 3 7s and the 2 4s. Put a parenthesis around those, and you get 60 distinguishable permutations. Pretty basic. All right, how many left here? 17 through 20. 17, skip it. We just did that. 18, skip it. We just did that. 19, how many 4-letter words can be made by rearranging the letters in bark? Do any of the letters repeat in bark? No. There's 4 letters. That'd be 4, 3, 2, 1, or that would just be 4 factorial. What if no letters repeat? If no letters repeat, then there's no denominator. You're done. That's just 4 times 3 times 2 times 1. 12 times 2 is 24. Done. Last but not least, the word problem can just be not a collection of numbers or letters. It could be an actual word problem. Mark has 3 $20 bills, 4 singles, and 5 tens. How many different ways can he organize these bills in his wallet? Last question. Well, even though he's got 3 $20 bills, these 3 20 bills are identical. It's like having 3 S's in Mississippi, even though there's 4 S's in Mississippi. I know you know what I mean. Okay. So how many total bills are in his wallet? 3 plus 4 is 7. 7 plus 5 is 12. If all of the bills were different bills, there would be 12 factorial ways to arrange them. But since 3 of the bills are identical 20s, you divide by 3 factorial. Since 4 of the bills are identical singles, divide by 4 factorial. Since 5 of the bills are identical tens, divide by 5 factorial. And if I plug all that into my calculator, I get an answer. And that answer is 27,720 permutations. All right, Pokely Dokleys, that's it. Questions? Ask. Your homework is on paper tonight. You'll get it on Classroom. Bye.